All right. Went out dancing last night. Been relaxing today, but we got an easy daily LeetCode problem, so feeling good. First of all, thank you so much for 100 subscribers. That was never my intention of doing this. My intention was to just get practice solving these problems and communicating while solving them. That technical communication, whether it be, seeing a problem for the first time or explaining a solution, you know, explaining the problem in a way that might be heard by another person, I think is something that's really good to practice and something I would really recommend, actually. So, very grateful for everyone that's joined in on this journey of mine. Yeah. Yeah, thank you so much. Let's see. So today we got an easy problem. Binary tree post-order traversal. Given the root of a binary tree, return the post-order traversal of its nodes. This is not a well-written problem, in my opinion, because, I'll be honest, I had to look up what post-order traversal was. Um, but yeah, it's look at the left, then the right, then the root. Okay? And then it does that recursively. All right, so that is actually pretty straightforward. What we're gonna do is just recursively go through it, and we're gonna get the value of the left. Well, we're gonna recurse through the left, and then recurse through the right, and then get the value of the node itself. And so every time it does that to a node, it's gonna be doing the same thing. So I would want to like draw it out, but yeah. So we're gonna define just a traverse. Let's see, yeah, traverse node. Or actually, let's call it Tn for tree node. All right. If Tn, so if it's not none, then we're going to say, let's see, traverse Tn dot left, traverse Tn dot right, and then return Tn dot val. Okay, so this will make sense. With recursion, I find that it makes sense once you start getting it written. But yeah, and if it's not, actually, yeah, we don't need to return anything. Oh, no, not return, sorry. We'll just append traversal. We're going to use a little bit of global access. Append tn.val. Awesome. That should do it, really. Let's see if this works. Sorry, I'm a little bit foggy today. Traverse root. Return traversal. Okay, so I'll see if this works, and if it works, then I'll explain it. Okay, it worked for that. Let's see if it works for all of them. Yes, it does, and it works. Wow, that's my best time yet. Yeah, that's a great solution. Yeah, pretty straightforward. Okay, so let's go through that. A post-order traversal is like a depth-first search, basically, but it's left to right. So we're trying to find the leftmost node, and then we'll find that brother. Alright, so recursively, let's see if I can. I'm explaining this very foggy. Let's do this better. So here's how this works. So we got this tree right here. And so we recursively traverse through it by saying, okay, traverse to the left, traverse to the right, and then once you're done doing both of those, append the value that you're on. All right? So remember that. So we have this right here. We have 1. This is our root. We traverse to the left. First we traverse to the left. Okay, bam. We're traversing the left. What do we do when we traverse? Now we're traversing 2. What do we do when we traverse 2? We traverse to the left again. 4. Okay? What do we do with 4? We traverse to the left. Nothing happens because it's none. Remember, this only happens if tn is not none, because none returns false. Okay? Okay, try traversing to the right. Nothing. Okay? Now we go to the third instruction. Append val. Okay, so we get 4. Awesome. We're done with that. We go back to 2. Now we traverse to the right. Same thing. Add 5. Go back. All right? Let's see. What was the output from there? Yep. Then we go back. We return 2 itself. Then we go back to this 1. Now that we've traversed to the left, we traverse to the right. We get the 3. We traverse to the left, nothing. We traverse to the right, 6. Left, right, nothing. Append the 6, append the 3, and then finally append the 1. I love it. Very graceful, straightforward. Yeah, that's today's problem. Thank you so much for joining.